Hey guys, we took notes on these questions, not in the middle of the packet, but then we took notes here in the back of the packet. Okay, and we got our pep talk. So we're going to finish these in a video. So let's take a look. Question number 1, it says, identify the dot plot, histogram, and dot plot for a given set of data. Okay, so we can do this. Let's dive right in. It says, Max collected data on the heights of his 20 classmates. All right, so it looks like I'm the height, 67, right about there. So it looks like I'm taller than half of the class. The tallest person is 76 inches. So we're just kind of getting the lay of the land here and reading the data off the chart. The tallest is 76 inches. The shortest is 59 inches, okay? The median is 65 inches. So that means half the class is taller than 65, half the class is shorter. Max collected the height on these classmates. The box plot shows the data. Complete the dot plot so it could represent the data. Okay, so let's count our dots here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have a total of 20 classmates. We know we can add this dot on the max, that we know. So this is called a 5-number summary. We know at least one person was 59. All right, so again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 data points. Now, we need half of the people. This is kind of an interesting question. I'm not sure there's like a precise answer here, but it's okay. So let me trace this down. We need half of the people over here, and I'm missing that. So 1, 2, 3, 4, 5, 6, 7, 8. So I need 2 more people over here and lots more people over here. Does that make sense? So I don't want to dig into the question, but it's probably something like this. A quarter of our data has to be here. So 20 divided by 4 is 5, meaning 5 classmates, 5 students have to be between that range, 5 students between that range, 5 between this range, and 5 between that range. Okay, so knowing that, I'm going to do a bit of a start over. Okay, knowing that, I need 5 people in each of these quarters. That's why they're called quartiles. Okay. So I'll add this one. 1, 2, 3, 4. I don't know, I need 10 down there. So I need lots more. I need 5 just in this first wing. So that could be multiple ones here. 1, 2, 3, 4, 5. Okay, so that's 5. Now let's go to the next wing. I'll use a different color here. Okay, this next wing, I need 5 students. So 1, 2, 3. I'll just add 2 more, 4, 5. Okay, and the next wing, the next quartile, I need 5. So 1, 2, 3, 4. We'll just add 1 more, 5. All right, now for the last one, we know we can add the max, right? This last is a quarter of the data. So 1, 2, 3, 4, and somewhere in there we could add that 5 data points. So in a box plot, the box plot is a 5-number summary, okay? What does that mean? So that means between the minimum and quarter 1 and the median and quarter 3 and your max, you know that there's a quarter of the data in each of those. You can kind of them as bin. This is 1 quarter of the data, 1 quarter of the data, 1 quarter of the data, and 1 quarter of the data. Nice. Okay, let's look at question number 2. In the spring, Sarah planted tomatoes consisting of 12 plants. Okay, so we can create a dot plot, and that's all they need, dot plot. Okay, so we have to order these least to greatest. So I have 0. We'll make a dot. Then it looks like I have a 4. I'll make a dot. Got a 5. 1, 2, 3 6s. 1, 2, 3 4 8s. 1, 2, 3 4 8s. 9. I got 1 9. 10, 11, 12. 10, 11, 12. I got 1 dot at 12. Okay, so we have 12, and that's all they want. Okay, so how do I finish this out? It says I'd have to label this. So this would be the number of tomatoes harvested. So I have to label my graph, number of tomatoes harvested. So could they ask you this? Not really. Nobody could grade this, but you could find a picture and kind of match it to the right picture. Okay, next question. City parks contain many flowering trees. This histogram below describes these heights. Okay, so here are the heights of the trees in meters. Small trees, medium, tall, extra tall, and giant. Okay? So it looks like under each of these, we have 2 of the small trees, 5 of the medium, 6 of the tall, 2 of the extra tall, and 2 of the giants. That's what we have in our histogram. What do we have in the next group? Notice there's 2 dots here. That's why there's 2 there. Notice there's 5 dots here. That's why there's 5. 1, 2, 3, 4, 5. Notice there's 1, 2, 3, 4, 5, 6 dots here. That's why there's 6. So just as we took our student data in class and made a histogram, it looks like they made this. See, there's 2 dots here, so I'll make that too high. And there's 2 dots in that bin, so I'll make that too high. This data and that data are exactly the same data. All right. Now look at dot plot B. I've got 2 here in this bin. 1, 2, 3, 4, 5 in this bin. 1, 2, 3, 4, 5, 6. 2 in here and 2 in there. It looks like the same data. So although the data is slightly different, I saw some small differences here. Did you see here? Here, this looks a little bit higher. This is laid out a little bit different. But in both dot plots, this could be that because it matches the quantity in each bin. 6, 2, and 2. Okay. I made that 3 high, so I'm just going to fix that. All right, so could dot plot A represent the data? Yes, because we have 2 between 0 and 4.999. We have 5 between 5 and 9.99. We have 6 between 10 and 14.99. And we have 2 between 15 and 19.99. And then we have 2 between 20 and 24.99. This is the data for dot plot A. Then when we look at dot plot B, right, we have the same 2, 5, 6, 2, and 2. So why could it be the histogram? Because it has the same quantities in each bin. Could B be as well? Yes, yes, for the same reason. All right, nice work. So inside our packet, we have some additional stats questions. So let's dig right in. It says, compare the following dot plot. The heights in inches of 12 random female high school students are shown. Make a dot plot. Okay, so here's 60 dot, 63 dot, 60, 59, 67, 62, 58, 65, 65, 65, 66, 72, done. The height of 12 female students are summarized in the dot plot. Select all that are true. So if this were 12 females in one survey, and these are 12 other females in a different survey, what can we tell here? Okay. It says the median heights of both groups is the same. So that's the number in the middle. So half of 12 is 6. So that would be 1, 2, 3, 4, 5, 6. So the median would be 64 here. 1, 2, 3, 4, 5, 6. The median would be 64. So the medians are the same. Yes. Both 64. The median height of both groups is the same. All right, the mean. Okay, so they switched from the median to the mean. Here, I think that would be different. I'm going to not pick that. I don't want to take time to calculate it, but I'd have to add these all up. All 12 up and divide by 12 to figure that out. But because the distribution is slightly different, I'm thinking it probably won't be the same. All right, the median height of the students in the second group is about 2 inches more. Not going to pick that because we know the median is the same. The median in both groups is 64. The mean height of the group in the first is about 2 inches more than the median height of the student in the second. I'd have to calculate this, and I don't want to take time tonight to do this, but I could calculate that. Again, so how would I calculate the mean? I'm going to add them all up, which is called the sum, and divide by the number of numbers. So I'd add them all up, 60 plus 63 plus 60, yada, 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 all the way, and then divide that by 12, figure out what that number is, and compare it to 64, which is its median. That's what the question's asking. Okay, both data sets contain an outlier. That looks false. No. 72 here is an outlier, so that's when a number is way out of whack. We notice this number is way off to the side. Here in these numbers, they're all clumped together. So 72 is an outlier. Only A has an outlier. All right, nice work. Let's take a look at question number 5. Compare the following box plots. The price of fast food in town A is shown below. Then they gave us town B. They already made us a picture. Which town has a higher percent of meal prices between 8 and 11? Okay, so our minimum is 4. And how many do we have? 12. Okay, so we can divide 12 in half. We get 6. So 1, 2, 3, 4, 5, 6. Okay, so our median here is halfway between $6.50 and $11.50. So what is that? $17, $18. So we get 9. So here at $9 is the median. Interesting, $9 is the median there as well. So what's the middle of the bottom? Between oh, they made this a little harder for us. This is kind of mean. We have to put these in order least to greatest. So this looks like $4 is the lowest, $5, $6, $6, $7, 4, 6, 6, 5, 7, $9, $10, 9, 10, $13. Oh, I got a $9.50 in there. $10, $13. Ooh, I had a 650. I got to wiggle that one in. All right, so again, I'm trying to order these things least to greatest. I have 4, 5, 6, 6, 650, 7, 9, 950, 10. Then before I jump to 13, I've got to get 1150, 1250, and ooh, I got to get 12. Spoke too soon. 12, 1250, 13. I think we did it. Okay. So how can I make a box plot? Halfway in the middle is 925. All right. So halfway between 9 and 950 would be 925. Okay, so that would be slightly different. So the median is 925. Right? And halfway between the bottom here is 6. So I'm going to put a dot at 6. And halfway between the top, it looks like, so that'd be quarter 3 would be 1175. So 1150, 1175. Okay. And then you have your max at 13, right? That's our max. So if we made a box plot, this is what it would look like. And that's very different. So town A and B look like two very different distributions. So now we can answer the question here. It says, which town has a higher percent of meals between 8 and 1150? So between 8 and 1150. Here, over half are between 8 and 1150. So we're going to have to say town B. Here, this would be less than half because each one is a quarter. So this quarter, but not that full quarter. Town B, because it's a full 2 quarters that are in that range. All right, the next question is, which town offers more inexpensive food? So cheaper food. So what is cheaper food? Well, half of their food is less than $9. Here, half of their food is less than $9.25. However, it looks like this has more food in this lower price range. Here, this has more in the upper. So we're going to say town A. Town A. Now, I picked a couple of questions on this learning goal. So I'm going to say I'm going to leave this strategy like that, and we'll call it good for that one, okay? Check us out on the next video for the next learning goal.